Hello. Cloning a hard drive is as easy as pie, as we'll see in a few minutes, and it doesn't need a computer. It can be any type of drive, usually SATA these days, but it could perhaps be an old IDE drive, or even a solid state device, 2.5 inch or 3.5 inch. And it can be from a computer or some other device, such as a personal video recorder or a CCTV system. The contents of the drive are of no consequence for cloning. If it's a computer hard drive, it can contain any operating system, or no operating system if it's just a data drive, and it can have any file system. Before explaining, I need to mention that this video was originally part of a large project about top-field PVRs, personal video recorders, affectionately known as TOPIs. But the project became too big and unwieldy and had to be split into segments. This video about cloning is one of those segments and still contains a couple of references to TOPIs. So how is all the above possible? Well, there are many gadgets available, including this one, which is the least expensive. It's dual purpose and can be used either for cloning with no connection to the computer, or it can be attached to the computer when it becomes a USB caddy for up to 2 drives. It's also a memory card reader and a 2-port USB hub. And at the top end of the price scale, there's USB 3 devices, like this high-class Innotek FD2102 at £39. Because cloning is done at electronic level, this unit performs the duplicating at exactly the same speed as the more expensive devices do. For example, both units will clone an average 500 gig SATA drive in 1 hour 20 minutes. If you fancy one of these devices but can't find one available anywhere online, you could try this company, Avesta. It's where I bought mine a month ago, and they had quite a few in stock. The other devices that you're about to see I bought through Amazon, including this second offering from Innotek. It's an FD2005 with bright front-facing LEDs. Making this video was just the excuse I needed for buying this baby. I'd often admired it on display in the fairly local computer shop that I used for bits and bobs. The red-black livery is a classic combination, and I like the rounded curves. Let's plug it in. On the back we have an on-off switch, a socket for the power lead, and a couple of connectors for cables to the computer. This is an 80 gig drive which is to be cloned onto a 200 gig drive. The process starts with a check that we're not trying to pour a pint into a half-pint pot. It checks that the target drive is equal to or greater in size than the source drive. Provided it meets that criteria, the cloning process starts. It copies the first sector from here onto the target drive, then the next sector from the source drive onto the target drive, and it keeps cycling through that until it gets to the end of the input drive. At that stage, the target drive is an identical copy to the source drive. In our case, it will contain 80 gig, let's say up to here, and then the other 120 gig will be unused. It could be allocated as another logical drive. This machine copies from A to B. They're marked A and B. So this one should go in the front slot, but let's horse around. Let's try and fool it. We'll put the small drive in the back, in slot B, and the larger drive, the 200 gig, in slot A. Put power on. We've got the blue LED for power. To make sure that you don't start a clone by accident, by just hitting off the red button accidentally, there's a two-step fail-safe process. You press it once and hold it to signify that you want to start cloning. It's made the check, but the system's failed because this one's larger than that, so it won't go any further. Let's swap them around. And try again. We have the power LED. Press and hold to say I want to start cloning, and off she goes. When cloning is completed, this red LED will go solid. If we come back to it and find that the LED has gone out, it means that it's hit a problem, and that will be fatal. It's either got a read error on the input drive or a write error on the target drive. Either way, it's curtains. 40 minutes later, the red LED has turned solid, meaning a successful clone. So that's 80 gig cloned in 40 minutes. Now let's clone a 120 gig. It's the Windows 7 drive from my PC, an SSD drive. Switch on. Yes, we have the blue power LED. Press the starter clone and press again to confirm. Off she goes. As this source drive is 50% bigger than the 80 gig we've just used, you might expect that the cloning process will take 50% longer, 60 minutes instead of 40. But no, the cloning time is governed more by the speed of the drives rather than the sizes. After half an hour, the red progress LED has turned solid, so we have another successful clone. That's 120 gig in 30 minutes, 50% more in 3/4 of the time. Another way of thinking about that is, if it can do 120 gig in 30 minutes, it would do 160 gig in 40 minutes. In other words, double in exactly the same time. Let's pull the drives. The 200 gig drive has been split into two parts, which I can think of like this: 120 gig Windows 7 and 80 gig unused that can be allocated for other purposes. I'll put this drive in the PC now and boot it up. Let's see what Windows makes of the new drive. Start, control panel, admin tools, computer management and disk management. Windows can see that it's 200 gig, which it expresses as 186, which is near enough. There's 120 gig WinPro 64 drive C, and the remaining 80 gig, which it shows as 74.5, as unallocated space. So I've got choices. I could create a new logical drive in that 74 gig, or I'm right clicking drive C and say extend the volume. Well, there we are. We've now got a much bigger Windows drive. Not that it's ever going to be used after this test. Right, I'm going to power down now and put the SSD drive in, because I can't abide this slow speed from the 200 gig drive. You never want to go back to an ordinary SATA drive after you've been using SSD. When a Toppy drive is cloned onto a larger capacity drive, the extra space becomes available automatically. When the drive is put in the Toppy for the first time, the Verify Files and Folders procedure kicks in and takes care of everything without ado. I've done 3 experiments with a source drive filled to the brim, only 4 megabytes free. That's just enough for a few minutes recording. Prior to the cloning, the target drive was prepared in 3 different ways. For test 1, it had been put in the Toppy and formatted in the usual top field way, which I gather is called FAT24. For test 2, it had been used in a Windows 7 computer and formatted as an NTFS drive. For test 3, it was formatted as an NTFS drive and then deallocated. Toppy handled all 3 scenarios exactly the same, with Verify Files and Folders making the new space available immediately. Out of curiosity, I tried the target drive each time in the HDRW hard disk read and write program in the computer before putting it in the Toppy. In all cases the recordings were visible, but the drive was locked, with the program saying that no writing was allowed. In the first case, where the drive had been formatted in the Toppy before the clone, it declared that the drive had write errors. For the other 2 cases, it said the drive was damaged. Regardless of what HDRW says, it appears that the status of the drive before cloning is totally irrelevant. Good old Toppy handles everything automatically. Almost needless to say, the program Topfield Hard Disk Read and Write has no problem with the clone drive after it's been fixed by the Toppy's Verify Files and Folders procedure. Given the simplicity and success in cloning with this unit, I had to test it in the PC. Again, it was dead easy. Windows 7 recognised it straight off and applied generic drivers. Using external drives in it was as straightforward as using memory sticks. It's clearly a USB 2 device. I then began to wonder how much better a modern USB 3 equivalent could be for cloning. So I went mad and sent off for a top-of-the-range executive Initec FD2102. The sales blurb points to the beautiful aluminium body that dissipates heat from the drives, and to the unobtrusive, very informative LEDs along the top. The next and final step is a comparison of a clone in this USB 2 unit against the same job in the USB 3. These 500 gig Seagate Barracuda drives will be used. But this raises the question, which of these 2 is the smaller and which is the larger, capacity wise? 500 gig is the nominal unformatted capacity. It's very rare for 2 similar drives, even from the same company, to be identical in size when formatted. They'd only be identical if manufactured in the same batch within the same factory, and that's because internal components can vary from batch to batch. Of course, companies like Seagate have many manufacturing plants, some even in different countries, so it'd actually be a surprise ever to get twins. The Toppy can be used as an easy way of finding a drive's actual capacity. Just go to Menu and then File. There are 2 numbers down near the bottom right hand corner. It's the second one we're interested in. The first is the number of unused megabytes, 419919 in this case. The second, 476932, is the actual capacity after formatting. Call it 477,000 for round figures. That's 477 gig. It's 500 gig according to the label, but that was its unformatted capacity on leaving the factory. The same procedure could be used for the target drive. It's going to be overwritten anyway, so it doesn't matter that the Toppy would want to format it before you could go to menu and then file. Switch on, start the clone, confirm. This is going to take well over an hour, so it's time to go and watch a bit of TV. One hour 20 minutes later, the camera's been switched back on, just as the clone comes to an end. The red cloning light has gone solid, so we have a successful clone. So that's the end of cloning with the USB 2 model, and we can bring in the USB 3 Initec device. Maybe I should have switched off first. Hello Initec. With your much more slender power adapter, lightweight, very easy to hold and manipulate. Plug him in. On the back of this device we have a proprietary USB 3 connector, power connector and an on-off switch. On this device, A is at the back and surprisingly B is at the front. This machine works quite differently. Far more information. If I press the button to switch on, we do get a blue LED to say power, but then we also get two other LEDs. A yellow one here to say there's a drive in slot A, and another one here to say there's a drive in slot B. If I take the drive out of slot B, its light's gone out. Put the drive back in, and the light comes back on again. And cloning is different procedure as well. You press and hold until a clone light starts here, and you release and press again. Now it's flashing on the left hand side, and it'll do that until it reaches the 25% mark, at which point that will go solid and the next one illuminates. The second one goes solid when it reaches 50%, and the third one starts flashing, and so on. Excellent. It's past the 25% mark. So the first light's gone solid and the second one's flashing. After 1 hour 20 minutes, all four blue progress indicators have turned solid. So we have another successful clone. Thank you, Mr. Initec. Exactly the same duration as the cheap and cheerful USB 2 model. So how does cheap and cheerful USB 2 compare with expensive, elegant USB 3? Quite well considering the price difference, £17 against £39. I'll make some comparisons using cocktail sticks to keep tally. Although plastic, USB 2 feels quite durable. I like the shiny red-black combination and the curves. It strikes me as classy. By comparison, USB 3 exudes quality. It looks and feels top of range. I'd be happy to have either of these on my desk, so I'm not allocating any points. USB 2 has 5 memory card slots, so we'll allocate a point. Un point. It can also act as a 2-port USB hub, so it gets another point. Un autre point. USB 3 has a dust cover, highly unusual, so we can have a point for that. It also has information lights showing when drives are plugged in, very reassuring. Another point. Whereas USB 2 has just one progress indicator, USB 3 has 4, and the dual purpose, as I found out recently. At the start of a clone, all 4 indicators jumped on, and I thought, end of clone, how can that be? Not even started yet, it's not done anything. And then I twigged, I'd put the drives in the wrong way round. So it gets a point for having error indicator. And then the second function is to act as real progress indicators. 25%, 50%, 75% and 100% complete. So they get an extra point. Regarding the power adapters, this fella's big and cumbersome. Gives a lot of clutter. Even the power lead is nearly 4 feet long. The USB 3's power adapter is minimal and lightweight, very easy to use, so it gets an extra point. The USB 3 lead is thicker. It has to be because it contains more wires. That's just the nature of USB 3. I can tell it's USB 3 anyway because it's got this blue insert in. Whereas the USB 2 one has the old white inserts. It's the same colour scheme that's used on the outside of computers. White is USB 2, blue is USB 3. When it comes to cloning speed, they're exactly the same, so there's no points to be allocated. USB 3 comes into its own though when they're attached to the computer. It's faster. I did some speed testing recently for another video. A 300 meg file in the USB 3 adapter took 10 seconds to copy. In USB 2 it took 10% longer, 11 seconds. If you're still awake at the end of this video and you'd like to see that testing, it's in another YouTube video that I made about copying files from a top-field personal video recorder, a Tf5810. So to see it, just click my name in the YouTube text below this video and select Tf5810 copy or something like that. Alternatively, you can Google those 2 words, Tf5810 copy, and get to the same place. I find that using USB 2 is clunky and hit and miss. Because drives can vary in thickness, old ones were thicker, modern ones are getting slimmer all the time. The bays, or slots, whatever you want to call them, have to be wide enough for the oldest drives. When a drive's inserted, it can rock backwards and forwards quite a bit, putting a strain on the connectors. USB 3 doesn't have that problem. It has fold down flaps that are spring loaded. When the drive's inserted, the flap applies gentle pressure against the drive so it doesn't rock about as much. It can if you push it really hard, but it tends to just stay firm. so it gets an extra point for that. It's a good feature. I find overall that this is very smooth for putting drives in and out. I want to be completely fair to USB 2 though. I have to admit that I'm a borderline doddery old fart. I turned 74 years of age just a few weeks ago, and 3 months before that I had a mild stroke where I was hospitalised and paralysed down the left side for a couple of days. That included mouth droop, so I couldn't speak properly. It was awful to be so tongue-tied. In some respects I'm still recovering from that, and it's why I sometimes talk slowly. Otherwise I don't enunciate properly. It's also left me with slight hand tremors, more so with the left hand. But with determination and perseverance, everything's coming back to normal. Slowly, bit by bit. So which is best? This fella has 1, 2, 3, 4, 5, 6. 6 credits. This one has just a couple. So now I can declare the winners. There's actually 2 winners. If you're on a budget or are only going to use it on very rare occasions, USB 2 is the way to go. Otherwise it's definitely USB 3. It's a real pleasure to use. The LEDs on this beauty are designed to be unobtrusive so that they can't distract anyone. They point upwards and they faint. That's a disadvantage to me. I find them too faint, especially in bright daylight. And I can only see the lights if I get close up and look down on them. Although I hate to part with such a lovely top quality gadget, I'm reluctantly returning it in favour of an FD2005 from the same company. Also has a dust cover. This Innotek FD2005 is exactly the same technical spec as the Innotek FD2102 that's being returned, so it'll work in exactly the same way. The differences are that this one has a rugged black plastic body as opposed to the lovely aluminium casing of the previous one, and it has bright front facing LEDs that can be seen from a mile off. Just what I want. Let's grab some power. The same configuration at the rear, proprietary USB port, connector for power and an on-off switch, but this time it's a rocker switch as opposed to the push switch. As with the previous models, this fella copies from A to B, but in this case A is on the left running from front to back and B is on the right running from front to back. I'm going to repeat the very first clone that we did, 80 gig onto 200. That took 40 minutes, and again I'll horse around. I'll put the larger drive, 200 gig, into slot A, and the smaller 80 gig into slot B. I do like these lights, very informative, telling us that the drives are inserted okay, and it's impossible to miss them because they're so bright. This is exactly what I wanted. Okay, let's see the error. Press and hold until the light comes on, and then press again. Yes, we have Blackpool illuminations, all the lights are on. The machine's now frozen until it's switched off. So we can remove the drives and put them in the correct way round. Switch on. Yes, both lights are on, so the drives are sitting correctly. Start the clone, press and hold till the light comes on. Release and press again. Off she goes. After 10 minutes the first progress indicator's gone solid, meaning that it's past the 25% mark and it's on to the next 25%. I love these bright LEDs. They make it so easy to see exactly what's going on. Oh yes, 40 minutes from the start we have Blackpool illuminations again. This time meaning a successful clone. Can you guess who's a happy bunny? This unit is definitely the best for me, and there's even a small bonus. Its price tag is just £35, giving a £4 saving. Happy days. Thanks for watching. For more information about Toppies, please click my name in the YouTube text just below this video and select from the list. Cheerio.